welcome to the High Performance Research Computing instructional videos. Today we will be talking about creating and submitting your first job file on Ada and Curie. Okay, first go ahead and open up a terminal and SSH into Ada or Curie. I will use Ada for this example since both clusters use the LSF job scheduler. Before I talk about creating a job file, you should be familiar with loading the modules. Modules allow multiple versions of software to be easily accessible. If you know what software you want to access, you can use the module spider command to see the available versions. For example, if you wanted to check the versions for MATLAB, you would type module spider MATLAB. Now you can see all the available versions for MATLAB on Ada. You can also do the same thing by typing in ml spider MATLAB. And again, you can see all of the available versions for MATLAB on Ada. Now, let's go ahead and load a module. So to load a module, you will type in either module load, or you can just type in MLL, and then the software that you want to load. So we'll go ahead and run one of these MATLAB modules. So we can go ahead and copy and paste one. And then press enter. Now if you type in ML, you can see that you have currently loaded MATLAB. If you want to switch versions of MATLAB, you need to remove the currently loaded module from your session by typing ml purge. And now when we type in ML again, we see that we have no modules currently loaded. Now that we've learned about the module system, we can go ahead and create a job file. So to do this, we can go to the HPRC wiki page to grab an example file. So we can navigate to Ada and then to the job file examples, and then we can go ahead and copy one of these examples, and then we can paste it into a text editor on Ada. Paste. Now you can edit the job file to fit the requirements for your job. So I'll go ahead and leave the example name as example job 1. The -w specifier sets the wall clock limit of your job. Setting the wall clock limit determines how long your job can run before it gets killed. Next, you can set the number of cores you need to run your program with the -n specifier. And in the following line, you specify the number of cores per node. In this example, we are requesting one core with one core per node, making it a single core, single node job. The number of nodes that the job uses is determined by the core count divided by the number of cores per node. So let's say you needed to request 20 cores across 2 nodes. You would set the -n specifier to 20, and then you would set the span p-tile option to 10 so that it allocates 10 cores per node. Next, you will decide how much memory to allocate per process. It is recommended that you set the per process enforceable memory limit equal to the memory per CPU. Remember to keep in mind the total memory per node you are requesting with these specifications, because this will determine which node or nodes your job gets placed on. For the output file, I'll go ahead and leave the name as example1 out. Finally, if you want to charge a different account than your default account, you should set the -p specifier to the account number. Otherwise, you can go ahead and erase this line if you want to charge your default account. And since setting your email address is optional, you can go ahead and delete that line. Alright, now we are ready to move on to the execution portion of our code. Make sure that your job specifications always come before any execution, and that the first line of any job script begins with the B sub directive. The execution portion is where you will put the commands to change directories, load modules, launch software, and etc. For this example, I'm going to run a simple Python script. Go ahead and type in Python and then Python script py. Then we can go ahead and exit the text editor, and to submit the job, you type in B sub $, and then the name of the job file. And then go ahead and press enter. When your job is finished, you can check the output file to see the output of the program along with any errors that may have caused your job to exit. So as you can see, it printed hello world and let me know that I have an error in my program. This concludes the Submitting a Job on Ada and Curie HPRC instructional video. For any questions, please email our help desk at help@hprc.tamu.edu. Thanks for watching.